Okay, so finding the distance between those 2 points, you're basically subtracting the x's, subtracting the y's, squaring them, and then adding them together, and then taking the square root. So that's how far apart those points would be. Now the order you subtract in really doesn't matter, you just need to be consistent. If I like subtract 3 minus a -2, then I have to go the same way here. But if you went -2 minus 3, you should get the same outcome in the end. So we actually end up with 5 squared and 5 squared, or -5 squared, so we end up with 25 and 25, I believe. So that's going to be like 7 point something. You can leave it as square root of 50. 50 at this point, again, 7 point, like 1 or something if you check it. And I only know that because the square root of 49 is easy, and then 50 is so close to it. So, ellipse is this, kind of oblong circle thing. Again, you've probably called it an oval before. An ellipse is something, though, that gets grouped with all these different circles. So these, all these different shapes. So like yesterday, Cash asked if the C and the C1, we're doing C2 today, was for circles. This whole chapter is called conics. So it's all these different types of shapes on our graph. Yeah, you can still call them circles. This is like a cousin of the circle. So they're kind of like, it's an oblong circle. All right. So our ellipse is basically, I guess we're going to call it like an oval type shape. So the word foci, I always think of the word focus. I think it's like a plural of focus. Foci are 2 points in our ellipse. And where these points come from is, and I should try to do like a demonstration with you guys on this, I just didn't get my stuff together today, is if I took these 2 points, which are going to be like around here, and if you, I had a string connected between those 2 points. If I dragged that string around using those focus points, it would draw our ellipse for us. And like I said, I'll try to get something together for us tomorrow to show you guys how that works. I need stuff like stuck up on the wall, so I did not do that this morning. So our focus points, we're going to talk about those 2 points. It's almost like picture like really wide, like eyeballs. So I'm going to see what I want to write for our vocabulary here. I'm going to say I'm a long axis. So the foci are 2 points on our long axis. And so when I'm talking about our long axis, this ellipse can either be like kind of a long way or like the tall way. So long versus tall. So these points are going to go in our ellipse. Like, what's that guy called? He's a yeah, Baymax. It's your Baymax eyes. The major axis is basically going to be the long line going through our ellipse. So it's going to be going flat across, is going to be our major axis. Actually, I'm going to use an actual line so my line doesn't look all wonky. So our major axis goes through the center there. Now, just like a circle has a center, there's still a center point. So, and that's going to be the midpoint of the major axis. It's going to be the center. I can try and eyeball that. Now on the end of that major axis, we have vertices. So like there's a point on the end of each of these that we call vertices. So it's the end point of the major axis. And so if you guys aren't color coding this, which I don't know if you are, like maybe trying to somehow label these, if you label them like numbers or something. Sorry, I should have said that ahead of time. So somehow that you're identifying these different points, or that you're able to, that what you write makes sense enough that you're able to kind of see where that would be. So even if you call them by a letter or something would be good. And you might have an idea now with our minor axis, it just basically is the other way. And that's what our co-vertices like work with. So the minor axis is going to go on the short way, the short axis. What color am I not used to? Gray. Our short axis here. I have to move that guy over. Close enough. And that short axis, it should still go through the center, even mine's a little bit off. And hopefully it seems reasonable that the co-vertices that are on the end of that short axis. Now some of these are not going to feel very important, and we're not going to use them as often because we're not going to get quite as deep as like maybe we would always, I mean like we're not going to do absolutely every type of ellipse problem there is. So some of these you're going to be like, why did she ever tell us those? Really, I'm only going to give you guys some of these, like some of this information. Obviously like knowing other ones are going to be helpful if we got more complex problems. But so kind of just be thankful if we don't end up having to use absolutely all of these. But so here we have our co-vertices there. Some of them are going to them all that useful. So to just graph it, depending on what they want us to put all on the graph, we'll kind of figure this out as we go here, but this information is going to all be helpful for us. So, all right, so depending on like a very small little important point, it tells us if it's going to be the long ellipse or the tall ellipse. And the way we tell the difference is if the A is bigger, like the A always has to be bigger than the B. So if the bigger number is first, it's going to be long. And I'll tell you guys how to think of that. The bigger number is first, it's going with the X. So think about X being longer. Does that make sense? So X is like the bigger value. Where if the bigger value is second, think of it being taller because the Y is taller. So the bigger numbers with the X, it makes it wider. The bigger numbers with the Y, it makes it taller. So kind of trying to watch out for that. So this little A is greater than B is kind of like, looks like a small fact, but it's kind of a big important point. Because if you're drawing an ellipse and you made it wide and it should have been tall, it's going to look a lot different from that. So, so our two formulas, that's the only thing that's different about them. And that little slight difference is going to make it look so different from one another. So this one, again, the orientation one means basically that it's wide. So So I wrote the orientation is a horizontal major axis. This is the long way to say it's wide.
Can we just say it's wide?
Yeah. All right, I'm going to teach you guys how to find all the different points on this. Good news is some things are the same as a circle. Where do you think the center is? H and K. Notice there's still an H and K, so we're going to put that in. Actually, we could probably do both of these at once to kind of, so the orientation on this one is going to be vertical major axis, so it's going to be tall. I'm going to do them both, I guess, at once. So the center is H and K. It's the same as a circle, so that doesn't change at all on either of these. But do notice that there's minus signs by H and K, so don't forget they're the opposite signs of what you expect. All right. The next thing is going to seem a little weird because we're throwing another variable in on top of all the variables that are already in there. So this next one's going to seem strange because it feels like I'm pulling it out of nowhere, but we'll get to where it comes from in a second. So the foci is basically, again, that's those two important points that kind of determine the size of our ellipse. It's a coordinate point. And that's going to be H plus or minus C, comma, K. And I'll explain that in a second here. And I'll write it down we'll write down this one as well. This one's going to be H and then K plus or minus C. So a couple of things. The foci is a coordinate point, and we need two of them. So this is where two of them come from. We add C, we subtract C from H, from our center. So we go from our center, and we go left and right from our center. This C is going to come in later, where they're going to explain that in a little bit. The C is going to come from our A and B. So that A squared plus B squared equals C squared idea, that does kind of apply here. It's not exactly the same, but it has like that relationship. And then on this one, the foci, again, start at the center and then you're gonna go up and down 2 different ways. So we'll talk about that in an actual example here in a little bit. The vertices are similar, but this one involves the A value. So it's H plus or minus A, comma, K. Our next one are co-vertices. I kind of just, like, it's, sorry, I want to make sure I have them right. So now the vertices are on the major axis, so we're changing the H's. Now the co-vertices are on the other axis, so we're going to change the other coordinate. So this one's going to be H, comma, it's going to be K plus or minus B. I'm thinking we're breaking our notes into 2 days.
We are.
I think so, just based off of, this is exhausting already. We'll get a couple graphed and then we'll, 'cause we have to do some writing of the equations like we did with circles, but completing the square for this is tougher than for circles. So I think we might need a 2-dayer.
Maybe 3.
Stretch it out.
All right. The major axis, again, is that horizontal axis, and the way to find where that is, it's basically the equation y equals k. So that makes sense because that's going to be the coordinate point, and then over here it's going to be y equals h. Or no, sorry, it's the other way, x equals h. It's vertical. And then the minor axis is just flipped from that. All right, and the A, B, and C relationship, like I said, it's close to the the Pythagorean theorem, but it's not exact, so that makes it a little bit strange. And so again, this is why we're so glad we have no cards for this, is because as much as these are similar, they're not the same. So this one's going to be C squared, or C equals square root of A squared minus B squared. And this one's going to be C equals square root of A squared plus B squared.